think login open 10 minutes before. Wait for 3-4 minutes.
Student have requested this accept.
Yes. Okay. Yes. Whatever I am getting. Did you install Scilab yesterday?
Yes, ma'am.
On mobile or laptop?
Laptop.
Laptop. Very good. Only 26, 27. So can you see? Hello.
Yes, ma'am.
Is it visible? Slide. Yes.
Yes, ma'am.
Is the slide visible?
Yes.
So shall I start? I will not be able to. So good morning, everyone. Yes. Is it visible and is it audible? Yes, all of you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Now I will start. Now I will not wait for other students to join. Now, the basic concepts of digital discrete time signals. You know what is the difference between analog signals and discrete time signals. The name itself suggests that it is discrete time signals means this is the time axis. Can you see properly? This is the time axis and this one is amplitude axis. So if the time axis is discretized, it is called as discrete time signal x of n. And the continuous time signal is represented by x of t. Here is it is a small t, keep in mind, and here is a small n. Now what is this time? Time is an independent variable. Now you are studying mathematics. Time is an independent variable, and which is dependent variable here? Yes. Numbers 5 to 10. 5 to 10. Hello. Hello.
मॅम तुमचा प्रेझेंटेशनचा फक्त तुमचा फाईल एक्सप्लोरर दिसतोय, पीपीटी दिसत नाहीये.
PPT is not seen.
No, ma'am.
Okay, wait. Can you see now?
No, ma'am.
No,
Still
ma'am.
not.
No.
Wait, wait. आणि ते स्क्रीन कुठे आहे तो शेअर केली. Can you see now?
Yes,
Yes,
ma'am.
ma'am.
Hello?
Yes, ma'am.
Can you see?
Yes.
Yes. Now, which is
Ma'am,
independent variable? What is the issue?
ma'am, just check for the last time for a request.
Yes. What that?
Student has requested, just check for last time.
So again and again, I am telling they should join in time. No. No, I am not getting requests. Mhm.
Okay, fine.
34 students are there total. Is this fine now? Hello? Is
Yes,
it okay?
ma'am.
Shall I start? Shall I start?
Yeah, ma'am.
Yes,
Ha,
yes.
ha. Now, which is independent variable here?
Time is it?
Yes,
Time, no?
time is independent variable. Why it is called as independent variable? Because see here, 10 a.m., 11 a.m., 12 a.m. Does it depend on the something? It
No.
will go on.
Hmm.
No. Now, what is the dependent variable?
It
Here is
depends
the
upon it.
amplitude.
Yes.
Amplitude is the dependent variable which depends on time. Is it okay? So why it is called a discrete time signal? Because this time axis has been discretized. What is meant by discretization? Yes, you are sampling. Is this okay?
Yeah, ma'am.
Now this is Now this is another example of discrete time signal stock market indices. So it will change according to the day and hours also, right? So this is again a discrete time signal. Then population statistics is again a discrete time signal. These are all examples of discrete time signal. So temperature measured, hourly temperature, average temperature, like this. So this is what is the temperature range. These are all examples of discrete time signal. Now what type of signal it is? Yes, speech
Analog,
signal.
ma'am. Yes.
Speech signal, which is analog or continuous time signal. Now why the name is continuous time? Because this time axis is continuous, means at any instant of time you will get some value. In the discrete time signal, you will not get at any instant of time. Suppose here is 16.5. Is there any value? No. Is this okay? So that is the difference between continuous time signal and discrete time signal. Now applications we have already discussed. If you want, you can read. Now, what is the advantages? These are already discussed in the first lecture, right? Now, books, you can use Prokey's book, and another is, yes, Oppenheim Schaefer. No, you use Prokey's book, which is mentioned in the syllabus. And
Ma'am, extremely sorry to disturb you, but there are some students waiting for your acceptance.
I don't know, but here I don't know what is the I have actually done. See, where I'm not unable to see the request.
Ma'am, I'll ask them to resend, then I'll tell you in 5 minutes to check again.
Huh?
I'll ask them to send the request again.
Hmm. So shall we wait or shall I start?
Let's wait, ma'am. They will also come.
Still, the problem is not solved for the yes,
No, ma'am.
Terna
There are
login.
there are there are some people who still have the issue. I don't know what it is, but there are.
Huh?
There are some people who are
Hmm.
facing issues. Ma'am, just check the Google Meet page, right? The request might pop up over there. Because people are saying in the group that they have sent it again and still nothing is happening.
Wait.
Okay, ma'am.
Hmm. Yes, is it audible?
Yes,
Yes.
ma'am. Yes, ma'am.
Now I will start. I have seen only 37 students are there. Let it be,
Okay,
and
ma'am.
henceforth tell them to join in time,
Okay, ma'am.
right?
Okay, ma'am.
Otherwise, again and again there is a disturbance. Ah. Now another is classification of signals. One-dimensional signal, for example, speech signal. Two-dimensional signal is image signal. Three-dimensional signal or m-dimensional signal is video signal. Now, what is the difference? Why two-dimensional? Because there are two independent variables. Here, m independent variables. Whatever we know is, suppose video signal, it can be a three independent variables. What are the independent variables in case of images? Is x-axis and y-axis. Is this okay? Yes. Pixel will have x coordinate and y coordinate. What is pixel? Pixel is picture element. So now that's why there are two independent variables. So image is a two-dimensional signal. Now what about video? Yes. Am I audible?
Yes, ma'am, you are.
So video, which are the three independent variables? Who will tell me? Yes. X-axis, y-axis is there for the video. Now in the images, see, this is the picture. It has two axes, x-axis, y-axis. For the video, you have one more axis, that is time axis, because number of frames per second you are transmitting. That's why one more axis is added. So there are three independent variables. Okay. Now continuous time signal, you know discrete time signal. Discrete time signal takes certain numerical values at specified discrete instants of time. And basically, how do you represent it? By a sequence of numbers. Now, continuous time signals, you have already done it. Signal, it is defined at every instant of time. While the discrete time, it is at discrete instants of time. And how do you represent mathematically is by sequence of numbers. Now types of signals, this is already explained. Analog signal, both time axis and amplitude axis are continuous. And what is the difference between discrete time signal and digital signals? Yes, in signals and system you have studied. Yes, roll number 1, 2, 3, 4. Digital signals, both are discrete. In digital signals, both are discrete. Time axis is discrete, y axis is also discrete. And computers and digital devices are restricted to discrete time signal processing, right? Now this is, it is a continuous analog signal. Then this one is discrete time signal. See, this time axis has been discretized. Then it is a digital signal means what? This, is it okay? Are you getting? Hello?
Yes, ma'am.
Are you getting?
Yes, ma'am.
हाँ.
मैम वन मोर थिंग, ये डिस्क्रीट टाइम सिग्नल में जो कर्व है वो वापस आप एक्सप्लेन कर सकते हैं? व्हाट इज डिस्क्रीट एक्चुअली?
This one, no?
Yes,
See,
yes.
this is the continuous time signal. Okay.
Yes.
Now, which is the time axis? This one is the time axis. Huh?
Yes, ma'am.
Huh. So this is your time axis and this is your amplitude axis. Now this time axis is, if you discretize means, yes, make the samples like this, cut it, right? So what you get? This amplitude at this instant, this amplitude at this instant, another amplitude. Can you see my cursor?
Yes, ma'am.
Huh. So you are getting at different instants of time amplitudes. In the continuous time, even if this gap is filled, you are getting some amplitude. But here only it is available at various distance of time. It is not available in between. So that is the difference between analog continuous time signal and discrete time signal. Is this fine now?
Yes, ma'am.
Only you have already studied sample and hold circuit. So you take the samples, or for example, on off switch, you are getting some output whenever switch is on. Whenever switch is off, you are not getting. That's it. Now, what is the difference between digital signal and discrete time signal? So in the discrete time signal, time axis has been discretized, while in the amplitude axis is also discretized. Are you getting?
Yes, ma'am.
Are you getting? So this is the discrete time uh, amplitude axis. These are divided. So here also in the discrete time signal, at you are getting 0 to direct 0.5.
Uh,
You are getting in
so
between
in
also.
simpler terms,
Are you
digital
getting the
signal is
difference?
not quantized, no, ma'am. किसी भी इंस्टेंस से वो बन सकता है ना डिजिटल सिग्नल.
Digital signal, both the axes are discretized.
Yes, yes. It can take value from x axis
Now
or y
you
axis.
tell me in the first
Yes.
case, you can get 0.7. बराबर है ना? Here it is not possible to get 0.7 number. Either you are getting this clear now?
Yes, ma'am.
Both the axes we are dividing or discretizing. This x of n sequence you have already indicates, yes, up to infinity on this axis and this axis, like this, right? Which type of signal it is? Infinite signal, right? Now, how do you convert continuous time signal to discrete time signal? By using sampling. So now suppose the sampling rate is, yes, sampling frequency is fs. So fs, sampling frequency, is 1 by ts, is the sampling period. And from xa of t, xa means analog signal, small t is continuous time. Simply replace small t by nts. So you get x of n. Is this okay? Is it okay? How to convert
Yes, ma'am.
continuous time signal to discrete time signal?
Ma'am, wait a second. Should we write? That is
You can write. You can
yes.
write.
Ma'am, you will be sharing this PPT with us soon, right?
PPT, everything is available on net also, no? This is, see, okay, if you want, I will.
Yes, ma'am, please.
Otherwise, instead of PPT, now what you do, you should have one book, or you search on the net. Ramesh Babu hai, and Salivan hai. Jayaraman
Ramesh
is also
Babu.
there. Jayaraman. I think you might have got the links for free books.
No, ma'am.
No,
Yeah,
ma'am.
these are shared in all the classes.
No, ma'am. We didn't get any.
Otherwise, first you check whether the PDFs are available. Jayraman, write down.
Ramesh, right?
हाँ,
Ramesh Babu.
Ramesh Bhau,
Bhau, okay.
and Jayraman,
Ramesh Bhau and Jai Raman.
Prokis
Okay.
and Prokis,
Can you spell it, ma'am?
Proakis.
Proakis.
You have syllabus with you. Syllabus.
You have to search the PDF.
You can check from the syllabus also.
Yes, ma'am.
All right, all right, ma'am.
Yes. So now, let us see definition of discrete time signal and system. This is the sampling circuit, you know already. This is the continuous time signal. Take the samples at small t equal to 1 second, 2 second, 3 second, 9 second, like this. And whatever the amplitudes you are getting, this is x of n. This is x of 0, x of 1, x of 2, x of 3, x of 4, like this, and so on. Is this fine? Yes? Are you noting?
Yes, ma'am.
You should have notebook and pen with you. We'll wait for the 2 minutes. And I think this is already been done in your signals and system. Only thing, brushing up is going on now. Is this fine? I hope everyone is listening.
Yes, ma'am.
Because these are the very important concepts. DSP is based on these concepts only. This is the sampling frequency, Fs. Operation on sequence. Now, input is x of n, output is y of n. Whatever you are doing, operations on the sequence is called as system. If the input signal to the system is discrete time signal, the output of the system will be discrete time signal. Then the system is discrete time system. Is this fine? And the operations can be addition, subtraction, multiplication, both addition, subtraction together, multiplication together, and so on. So these are very basic operations. There is no integration, there is no derivative. Now operations on the sequence. W1n equal to xn into yn. Multiplication or scaling. So you are scaling a sequence by a into x of n. Addition of the two sequences. W3n is xn plus y of n. All these operations you have done in signals and system. Now, another operation which is important in the is the time shifting. So you have x of n signal. How to display x of n minus capital N? Yes. Who will tell me? Roll numbers 5 to 10. Can you answer? Time shifting property. Yes. Towards right shift or left shift?
Minus n is the right shift.
Right shift, correct. N plus 1 is
Left shift.
left shift. It is called as unit advance. This is called as delay. This must be known to you. And this one is time reversal or reflection. X of minus n, whatever is on this side will be shifted on another side. That is x of minus n. Now, see, unit sample sequence or unit impulse. The name suggests unit means 1. So amplitude is 1, right? Now, at what time it is? At n equal to 0, and rest of the times it is 0. That is called as unit impulse signal. Only it will take value 1 at n equal to 0. N equal to 0 means at argument equal to 0. Now, if the argument is n minus k, yes, when it will become 0? At n equal to k, it will become 0. So, at n equal to k, amplitude will be 1. So, now your signal will get shifted from this place to another place. Are you getting? Is it okay?
Yes, ma'am.
Ha. At least roll number, see, cyclically roll number 5 to 10, 10 to 15, 15 to, they should keep responding, no? Ha. What is unit step signal? You denote by u of n, and u of n equal to 1 when n greater than or equal to 0. This is n greater than or equal to 0 on this side. This one actually 0, 1, 2, 3, 4 like this. This is 0. So here is u of n equal to 1 for positive side of n, and it is up to infinity. It is not shown here, but it will go up to infinity. Right? Now unit step signal shifted by k units, k samples, u n minus k, means this will be shifted towards right side by how many? By k samples. Otherwise it is on this side, it is 0. So it is 0 for n less than k. Here it is 0 for n less than 0. When the argument becomes 0, signal becomes 0. Are you writing? Yes?
Yes, ma'am.
Ha. Because this subject requires practice. Home also you must practice. Unit sample and unit step signals are related as follows. Now how they are related in this way? U of n equal to delta of n minus m. Yes? How these are related in this way? See here, what is delta n? Is impulses. And if you take sample all the samples and you add all the samples, means you are adding like this. See here, this is delta signal. Again, another one delta signal I can draw like this. Another shifted delta signal I can draw like this. Another shifted delta signal I can draw like this, like this. So if you go on adding all these signals, you get u of n. Is this okay? Yes? So you can write like this: u of n equal to summation of delta n minus m, m equal to 0 to infinity. And how delta n can be related with u of n? U of n minus u of n minus 1. That is how it is related. Now this is sinusoidal sequence. All this also you have already studied. It is cos of omega 0 n plus phi, cosine wave, which is discretized. Right? Now this is plus phi, omega 0 n plus phi, means, yes, phase shift, right? For all n, this is shifted by phi. Now what is the difference between digital frequency and analog frequency, and the relationship? That also you should know. This is called as exponential signal. A e to the power j omega 0 n phi. So A, this is the real part, cos theta plus j sin theta, imaginary part, right? Omega 0 is called as frequency of the complex sinusoid, and phi is called as phase. Now sequence representation. This is real exponential sequence. Exponential means alpha to the power n, right? N equal to 0, 1, 2, 3, 4. So it can be 0, 1, 2, 3, 4. It will go on increasing. That's why it is called as exponential sequence. It is exponentially, it is increasing. Now complex exponential. A e to the power j omega n. Omega is frequency of complex exponential sinusoid, and A is a constant. A is amplitude. A into e to the power j omega n. Again, cos theta and sin theta will come here. Now the systems. Linear time invariant system. Can you define linear system? Yes. Roll number 5 to 10, 10 to 15. Can you define linear system? Yes. Hello. Who will define linear system?
Linear system क्या कहते हैं, satisfies principle of superposition.
Yes, very correct, Bade. Pranav.
Thank you. Thank you.
Now, linear system and time invariant, that we'll see afterwards. LTI is linear and time invariant. A system is linear if and only if it satisfies the property of superposition theorem, that is additive property and scaling property. If you are applying input x1n plus x2n to the system, you are getting outputs y1 plus y2n, where output y1n is the output of the system when only x1n is applied, and y2n is the output of the system when x2n is applied, right? That is superposition additive property. Another is scaling property. If your input is scaled by A, output also should be scaled by A, where A is arbitrary constant. If both the properties are satisfied, then the system is said to be a linear system, right? And this combined will be a superposition theorem. Now, this is okay, you know. Now, classification of discrete time system, a linear system, a non-linear system. In the curriculum, we'll be studying a linear systems. So linear means this output is linear combination of inputs. AX1 plus BX2, these are all linear combinations of the input. Non-linear system means output is logarithmic. It is not a linear one, or exponential, or logarithmic, or like this. These are called as a non-linear system. I think you must have solved examples also. Check whether the system is linear or not. Check whether the system is time variant or invariant. Now another type of system is time invariant system, right? Who will tell now time invariant system? Yes. What is time invariant system? Yes. Time invariant system. The definition.
Ma'am, in simpler terms, I
Devashri
can.
Raj. Das,
Yes.
I am listening. Yes.
Yes,
Hmm,
ma'am.
well,
Time invariant system has a time dependent variable, and it is not a direct function of time, we can say. We cannot express it with time dependent system, no, ma'am.
see, time invariant means output. If you are shifting input certain by time interval t0 or n0, output also should be shifted by the same amount of time. Means characteristic of the system is independent of, yes, time. Characteristic
Hmm.
of the system does not change with the time. Say for example, at 11 o'clock you are performing one experiment. You are giving input as 5 millivolt, you are getting output as 5 volt in the amplifier you perform in the lab. Is it okay? Now at 12 o'clock again you are performing the same experiment. You are giving 10 millivolt, output is again it should be amplified by the same amount. Is it okay?
Yes, ma'am.
So response of the system should not change with the time. Whatever experiment you are performing at 11 o'clock, same experiment if you perform at 12 o'clock, your response will not change. Now, which are time variant system? Suppose any system which is dependent on temperature. The system which is dependent on the temperature. So temperature varies, environmental temperature. It varies from morning to evening, right? So that will be time dependent. But in the curriculum, we'll be studying time invariant systems. Is this okay?
Yes, ma'am.
Yes. So which system you will prefer? Time invariant. So characteristics should not change with the time. Now the causal system. Yes. Yesterday we discussed causal system. Who will answer now? Causal system.
The output depends upon the present input only.
So in the causal system, output depends on present and previous.
Past and current, no, ma'am.
Past and current. That's what past, previous, present, and previous. Yesterday we were discussing about the signal. Signal is different. System is different. What is the difference between signals and system? Signal is represented by x of n, while the system is it has input, it has output, and how output varies with the input. That is called a system. So now causal system means output depends on present and previous input. It does not depend on the future input. Now, can you tell me one example? Yes. Can you tell me one example? Pranav?
Trying to think, ma'am.
Example of causal system. I'll give you a system. You tell me whether the system is causal or not. Is it okay?
Yes, ma'am.
Everyone is listening? The system is, suppose
Example.
you are see, examination is a system. You are studying, then you are writing the paper, and you at the end of the semester you are getting the results. This is the system. Is this okay? Now whatever the marks you are getting, it will depend on which factor? What are the factors? Now can you tell me this is a causal? Yes, whatever you have studied before examination.
The study, whatever you do next.
Yes. So whatever studies you did before examination, your marks will depend on that. Your marks will not dependent on After the paper is over, you are studying. Right? It is useful for the future, but your marks will not depend. Marks will not change. So that is the example of a causal system. And in reality, we always prefer a causal system. Now, which is a non-causal system? Can you give me a real-time example of non-causal system? Whenever you are going out, you are taking umbrella. Is this okay? If you see clouds, is it okay? Yes? Are you getting?
Yes, ma'am. Yes.
So now, this action, whether it is a causal or non-causal, action of carrying umbrella,
It's non-causal, no, ma'am, because we are
non-causal,
thinking
because
about
we
future
are
inputs.
predicting, yes,
Yes.
we are predicting that it may rain. That's why we are taking the umbrella. So this is a non-causal. Is everything clear?
Yes, ma'am.
And whenever you do in the practice, you will be designing a causal systems, because these are reliable only. We don't know what will happen. Now stable and unstable. Stable system, for every bounded input, the output is also bounded. Right? Means if input is finite, output has to be finite. And what is unstable system? Yes?
If any one of the inputs is not finite,
Yeah, yes, that becomes infinite. So which system you are going to prefer in practicals? Stable system. If the output is infinite, it is of no use. So you go always for stable system. How do you check whether the system is stable or not? You have studied control system. Tell me now. Control systems you studied, subject. It is very important concept. I think in signals and system, whether you studied, check whether the system is stable or not. Yes or no?
For a stable system, it should
Only,
be it should
only
give
two,
output
three
for a
students.
bounded input something.
That is okay. That is the definition. But how to check? See, if the system is digital system, you use Z transform. If the system is analog system, you use S Laplace transform. How do you check whether the system is stable or not? Only one or two students are answering. What about others? These are all the concepts. These are all the questions of signals and system. Yes, Rahul Thorat. Otherwise, I will not mark you present.
Ma'am, poles and zeros should be left side of the real axis for a stable
Not
system.
poles and zeros. Check again. Pole should lie on left side. But at least you can recall. Now, what about Z transform? When the system is said to be a stable system in the discrete time system or digital system, your pole should be inside the unit circle. Then the system is a stable system. Got it? This is the test how to check whether the system is stable or not. Now impulse. This we'll see next time, right? Is this okay?
Yes, ma'am.
So now what you are supposed to do, you are supposed to write only your number, because I can see your name. Whatever you are login, no, you are login through your own mail ID. So I can see your name. Only write down roll numbers in the chat box. Is this fine?
Yes.
Yes. And next time what you are going to do, I will give you one assignment, because you have holiday on Saturday and Sunday. Skill based lectures are there, but still, unless you solve, you do something, you must practice, right? I'll give you few examples and you do it. Write down only your roll number. Name I could see